we need to write each fraction as a decimal. So what we need to remember in order to do this is that some fractions have place values. We know that after the decimal point, we have our tenths column and then our hundredths column. So what we need to do is to find equivalent fractions for these fractions, which have either tenths or hundredths as the denominator. So for this first question, we can find an equivalent fraction to 1/2, which has a denominator of 10. We use multiplication to find equivalent fractions. 2 times 5 is 10, and what we do to the denominator, we need to do to the numerator as well, and 1 times 5 is 5. So we know that 1/2 is equivalent, so the same size, as 5/10ths, and tenths have a decimal place value. We know that the first digit after the decimal point is the tenths digit, so we can write 1/2 as 0.5 because that's the same as 5/10ths, and 5/10ths is the same as 1/2. Now we have 1/4. Here we can't change it to tenths because 10 isn't a multiple of 4, it's not in the 4 times table. But 100 is a multiple of 4, and we know that the second digit after the decimal point is the hundredths digit. So we can find an equivalent fraction to 1/4, which has a denominator of 100. 4 times 25 is 100, and what we do to the denominator, we do to the numerator as well, and 1 times 25 is 25. So 1/4 is the same as 25 hundredths. So that's 0.25 as a decimal, because remember, if we've got a fraction over 100, we can't go past the hundredths place value, so we can only have 2 digits after the decimal point, which means the 2 gets shifted over to the tenths column. Now we have 1/5. We can change that into tenths. 5 times 2 is 10, so if we do the same to the numerator, 1 times 2 is 2. So, because 1/5 is the same or equivalent to 2/10ths, we write it as a decimal as 0.2, because the first digit after the decimal point is the tenths digit. Finally, we have 1/50th. Now 100 is a multiple of 50, because 50 times 2 is 100, so if we do the same to the numerator, 1 times 2 is 2, so because 1/50th is equivalent to 2 hundredths, we can write that as 0.02, because remember, the second digit after the decimal point tells us our hundredths, that's the hundredths digit. So let's go back and have a look at this first question. We had 1/2, but we changed that to 5/10ths so that we could write it as 0.5, and you can see exactly the same amount of the fraction bar or rectangle is shaded. We've just changed it into tenths because with tenths we have a decimal place value. Then we had 1/4. If we take away the quarter grid and put a hundredths grid on top of it, you can see that now we have lots of half rectangles shaded, but if we do some rearranging, you can see that that's equivalent to 25 hundredths, so that's 0.25. You can imagine that 2 of these lines are tenths, and then we have 5 hundredths. Then we had 1/5. We changed that to 2/10ths so that we could write it as 0.2. Then we had 1/50th, which is the same as 2 hundredths, so that's 0.02. We need to write each fraction as a decimal, and the way to do this is to remember that some fractions have decimal place values. So we know that the first digit after the decimal point is the tenths digit, and then the second digit after the decimal point is the hundredths digit. So we can find equivalent fractions for the fractions that we have here with a denominator of either 10 or 100, because then we'll be able to write them as a decimal. So first we have 3/5. Now 10 is a multiple of 5, so we can find a fraction equivalent to 3/5, which has a denominator of 10. We use multiplication to find equivalent fractions, and 5 times 2 is 10. What we do to the denominator, we do to the numerator as well, and 3 times 2 is 6. So now that we know that 3/5 is equivalent to 6/10, which means it's the same size as 6/10, we can write it as a decimal, because the first digit after the decimal point is the 10ths digit, so we can write that as 0.6. Next, we have 3/4. Here, we can't change 3/4 into tenths because 10 is not a multiple of 4. It's not in the 4 times table. But 100 is a multiple of 4. So, we can change 3/4 into hundredths. Now, 4 times 25 is 100. If you think counting in 25s, we have 25, 50, 75, and the fourth multiple is 100. So what we do to the denominator, we do to the numerator as well. So with 3 times 25, well, we can count 25, 50, the third multiple of 25 is 75. So 3/4 is equivalent to 75 hundredths. Remember, that denominator of 100 tells us that we can't go past the hundredths place value column. So we need to write 75 hundredths as 0.75. So the 7 gets shifted over into the tenths because we can't go past the hundredths column. And remember, the second digit after the decimal point is the hundredths, so we can only have 2 digits after the decimal point if we have a denominator of 100. Now we have 4 over 25. Well, 100 is a multiple of 25, and 25 times 4 is 100. What we do to the denominator, we do to the numerator as well, and 4 times 4 is 16. So the denominator of 100 tells us that we need 2 digits after the decimal point, so we write 16 hundredths as 0.16, so the 1 gets moved over to the tenths. Finally, we have 12 50ths. Well, 100 is in the 50 times table because 50 times 2 is 100, so we do the same to the numerator, and 12 times 2 is 24. So now that we know that 12 50ths is equivalent or the same size as 24 hundredths, we know that we can write it as the decimal 0.24. So let's have a look at this first question. We had 3/5. We found that that was equivalent to 6/10, and notice the same amount of the rectangle or fraction bar is shaded blue, but splitting it into tenths is important because tenths have a decimal place value, so we could write that as 0.6. Then we had 3/4. If we take off the quarters grid and put a hundredths grid on top of it, we need to do some rearranging because we have some half rectangles, but when we do that, we can see that we have 75 hundredths, so that's 0.75, because you can imagine 70 of these hundredths, so these 7 lines that go all the way down are the same size as tenths, so that's why the 7 digit gets shifted over to the tenths column. Then we had 4 25ths. We changed those 25ths into hundredths, and that meant that we had 16 hundredths, so 0.16. Finally, we had 12 50ths. We changed that into 24 hundredths so that we could write it as the decimal 0.24. Write the number the arrow points to as a decimal. So let's have a look at this number line. To get from 0 to 1, we have 1, 2, 3, 4, 5 lines. So each of these lines must be 1/5. So what is 1/5 as a decimal? Well, remember, decimal place values are tenths or hundredths. 5 times 2 is 10, and 1 times 2 is 2. So, because we know that 1/5 is equivalent or the same size as 2/10ths, we know that that's 0.2 as a decimal, because the first digit after the decimal point is the tenths digit. It's the tenths place value. So here, because the arrow is pointing to 1/5, as a decimal, we write that as 0.2. So where is the arrow now? Well, that's 4/5 after 0. And if 1/5 is 2/10ths, 4/5 must be 8/10ths, because 4 times 2 is 8. So 8/10ths is 0.8. First digit after the decimal point is the tenths digit. So now the arrow is pointing after 1, so we will have 1 whole, and that's 1, 2, 3/5 after 1. Now 3/5 is the same as 6/10ths, so that's 1.6, because it's after 1, and 3/5 is the same as 6/10ths, and the first digit after the decimal point always tells us how many tenths we have. So now the arrow is after 2, and it's 2/5 along, so that's 2.4, because 2/5 is 4/10ths. Now this number line is slightly different. This time we have 1, 2, 3, 4 lines to get from 0 to 1, so each of these little lines must represent 1/4. Now we can write 1/4 as a decimal by changing it to hundredths. 4 times 25 is 100, and 1 times 25 is 25. So, because we know that 1/4 is 25 hundredths, we know that as a decimal that's 0.25, because the denominator of 100 tells us that we can't go past the hundredths place value, and the hundredths is the second digit after the decimal point. So here, the arrow is pointing after 2, and it's pointing 1/4 after 2, so 2 and 1/4 is 2.25, because 1/4 is 0.25. So where is the arrow now? Well, it's 2/4 after 0, and 2/4 is 50 hundredths, so 0.50, but rather than 0.50, we can just write 0.5, because we don't include zeros if they're on the end of decimal numbers. The other way of thinking about this question is to notice that the arrow is pointing right in the middle or halfway between 0 and 1. And if we know that 1/2 as a decimal is 0.5, because 1/2 is the same as 5/10ths, we might be better off getting our answer that way instead of thinking about quarters. So here, the arrow is pointing to 3.5, because it's halfway between 3 and 4, or because it's 3 and 2/4, and 2/4 is 0.50, so just 0.5. And finally, we have something that's 3/4 after 4. Now 3/4 is 0.75, because 3 times 25 is 75, and it's after 4, so that's 4.75. Now, if we look at this number line, we have some longer lines and some shorter lines. Let's look at the longer lines first. To get from 0 to 5, we have 5 longer lines. Notice 0, 1, 2, 3, 4, 5. So these longer lines must represent whole numbers. And that means the shorter lines must be halves, because they're halfway between the longer lines. So 1/2 as a decimal is 0.5, because that's the same as 5/10ths. So now the arrow is pointing to a longer line, and remember the longer lines were whole numbers. So after 5 we have 6, so that's just 6 wholes. And here we have 0, 1, 2, so that's just 2 wholes. But here we have 5, 6, 7 and a half, so that's 7.5, because 1/2 as a decimal is 0.5. And now we have 5, 6, 7, 8, 9 and a half, so that's 9.5. If we have 1 part out of 10, we have 1/10, and that's written as a decimal 0.1, because the first digit after the decimal point is the 10ths digit. So on these place value counters, I've written 1/10, but I could have written 0.1, because 0.1 is the same as 1/10. Now, if we have 1 part out of 100, we have 1/100th. We get 100th when we divide a whole by 100 or a tenth by 10. So you can see that the rectangle is now split into 100 pieces, and we have one of those pieces, so we have 1/100th. We can also get 100th when we divide a tenth by 10. So if we go back to the previous slide, we can see amount shaded was 1/10. And now if we go to the next slide, we can see that when we had a tenth, we had all of these pieces shaded as well. But now we've only got one of the 10 pieces that we had shaded, so dividing a tenth by 10 gives us 1/100th. And we can write 1/100th as a decimal. That's 0.01. So remember, the first digit after the decimal point is the 10ths digit, but then the second digit after the decimal point is the 100ths digit. That tells us how many hundredths we have. And again, though the place value counters write 1/100th as a fraction, we could have written 0.01 on these place value counters, because that's the same as 1/100th. Now, if we have 1 part out of 1,000, we have 1,000th. And we've still got this rectangle split into hundredths, but you can imagine each of these little rectangles split into 10 pieces. That would mean that the rectangle was split into 1,000 pieces. Now we can't show this, because if I split each of these rectangles into 10 pieces, you wouldn't really be able to see anything. And you probably can't even see this tiny little blue sliver that we've got here to show 1 part out of 1,000. So we get 1,000th when we divide a whole by 1,000 or 100th by 10. So each of these little rectangles are still showing 1/100th, and if we have just a tenth of that, we have 1,000th. So the 1,000ths digit is the third digit after the decimal point. Remember, we have our ones before the decimal point, then after the decimal point we have tenths, hundredths and then thousandths. And we can show a place value counter for our thousandths, and though it's written as a fraction, again we could have written 0.001 on this place value counter. So you might be able to see this tiny little bit of the rectangle shaded, and that's 1,000th, because if we had 1,000 of these tiny little blue rectangles, we would have our whole rectangle shaded. So we know that our whole number place value columns are our ones, tens, hundreds, thousands, 10,000s and 100,000s, and we also know that when we have 10 of something, we can go to the next place value column along. So 10 ones make 110, 10 tens make 100, 10 hundreds make 1,000, and so on. And we also know, going the other way, that if we divide 100 by 10, we get a 10. If we divide 10 by 10, we get 1. And it carries on into our decimal place values. So if we divide 1 by 10, we get 1/10. If we divide 1/10 by 10, we get 100th. And if we divide 100th by 10, we get 1,000th. And it also works going the other way. So if we have 10,000ths, we have 100th. if we have 10 hundredths, so 10 of these green counters, we have 1/10, and if we have 10 tenths, we have 1/1, or 1 whole. So look at this number. We have 294.35. Which digit is in the tens place? Well, when we have decimals, we need to count place values from the decimal point. So the digit before the decimal point is the ones digit, and then the digit before that is the tenths. So in this number, we have 9 tens. Now, which digit is in the tenths place? So it's important not to get confused between tens, which is a whole number place value, and tenths with a th, which is a decimal place value. Now the tenths digit is the first digit after the decimal point. So for this number, if we look at our decimal point, the first digit after it is a 3, so that's 3/10. Now, what is the value of the digit 5? So we can find the digit 5, and we can see that that's the second digit after the decimal point. Now the second place value column after the decimal point is the hundredths place value column. So that 5 must stand for 5 hundredths. So we can write that as 0.05, so the 5 is the second digit after the decimal point, or we could express the value as a fraction, so as 5 hundredths. Now look at this number. We have 813.465. Which digit is in the hundredths place? Well, the hundredths digit is always the second digit after the decimal point, so we have a 6 in our hundredths. Now, which digit is in the hundreds place? Remember, when we have decimals, we count place values from the decimal point, so we have ones, then tens, then hundreds, so we have an 8 in our hundredths place. Now, what is the value of the digit 5? So, the digit 5 is the third digit after the decimal point, and the third place value after the decimal point is the thousandths place value. So, this 5 stands for 5 thousandths, and we can write 5 thousandths as 0.005, so that the 5 is the third digit after the decimal point, and it has to be the third digit, because if it was the second digit, it would be in the hundredths, and if it was the first digit after the decimal point, it would be in the tenths. So we show 5 thousandths as 0.005, and that's the same if we express the value as a fraction as 5 over 1,000. We need to write these decimals as fractions. So first we have 0.9. Now the first digit after the decimal point is the tenths digit. So what we can do is draw a line across from the decimal point and a denominator of 10. So we have 9 tenths. Now we have 0.09. So this time the 9 is the second digit after the decimal point, and all of our other digits are zeros. What we can do, because we have 2 digits after the decimal point, and the second digit is always the hundredths digit, is draw a line across from the decimal point, and this time, because we have 2 digits after it, we can write a denominator of 100, so 2 zeros. So our answer is 9 over 100, because our 9 is in the hundredths place. Now, for 0.009, we need to remember that we have tenths, then hundredths, then thousandths. So we can draw a line across from the decimal point and write a denominator of 1,000, so 3 zeros, because we have 3 digits after the decimal point. So that's 9 over 1,000, because the 9 is in the thousandths place. Now we have 0.89. So there are 2 digits after the decimal point, and the second digit after the decimal point is the hundredths digit. So what we can do is draw a line across from the decimal point and write a denominator of 100. So that's 89 hundredths. Notice the answer is not 9 hundredths. That would be 0.09, but we have 0.89, and 8 tenths is equivalent to 80 hundredths. So that gives us 89 hundredths, taking both digits together. Now 0.089. So we have 3 digits after the decimal point, and after the decimal point, the third digit is the thousandths digit. So we can draw a line across from the decimal point and write a denominator of 1,000. So that gives us 89 thousandths, because 8 hundredths is the same as 80 thousandths, and then adding that to the 9 thousandths gives us 89 thousandths. Finally, we have 0.389. There are 3 digits after the decimal point, so we can draw a line across from the decimal point and write a denominator of 1,000, because the third digit after the decimal point is the thousandths digit. So that gives us 389 thousandths. Now let's take a closer look at some of these questions. We saw that 0.009 is 9 thousandths, because the third digit after the decimal point is the thousandths digit, and all of our other place values show 0. But now let's take a closer look at 0.089. So we have zeros in our ones and tenths place value columns, but we have an 8 in our hundredths and a 9 in our thousandths. But 8 hundredths is the same as 80 thousandths. They're equivalent fractions, because 100 times 10 is 1,000, and when finding equivalent fractions, what we do to the denominator, we do to the numerator as well, and 8 times 10 is 80. So we can add 9 thousandths to that, and because we've got a common denominator, that stays the same in our answer, and 80 plus 9 is 89. So that's why 0.089 is 89 thousandths. Now let's take a closer look at 0.389. We have 0 in our ones, then 3 in our tenths, 8 in our hundredths, and 9 in our thousandths. But 3 tenths is the same as 300 thousandths. That's because we use multiplication to find equivalent fractions. 10 times 100 is 1,000, and what we do to the denominator, we do to the numerator, and 3 times 100 is 300. Then we have 8 in our hundredths place value, but 8 hundredths is the same as 80 thousandths. That's because 100 times 10 is 1,000, and 8 times 10 is 80. So if we add the 9 thousandths to that, we now have our fractions with a common denominator, so the denominator stays the same, and 300 plus 80 plus 9 is 389. So that's why our answer is 389 thousandths. Let's just take one last look at this middle question. 0.089. The 8 is in our hundredths place, so we can show 8 hundredths place value counters, and the 9 is in our thousandths, so we can show 9 thousandths place value counters. But remember, we can exchange one of our hundredths for 10 thousandths, and if we do that to all of our hundredths, that gives us 89 thousandths altogether. We need to write these fractions as decimals. So first we have 3 tenths. As a decimal, that's 0.3, because the first digit after the decimal point always tells us how many tenths we have, and we have 0 before the decimal point because we can't have an empty ones column, but we don't have any whole numbers. Now 3 hundredths is written as a decimal as 0.03. That's because the second digit after the decimal point is the hundredths digit, and we have 3 hundredths, So we need a 0 in our ones, but also in our tenths to show that the 3 is in the hundredths place value column. Now we have 3 thousandths. That's 0.003 because the third digit after the decimal point is the thousandths digit, and we have 3 thousandths, so we need zeros in our ones, tenths and hundredths to show that the 3 represents 3 thousandths. Now we have 54 hundredths. The hundredths digit is the second digit after the decimal point, and the denominator of 100 tells us that when we write the fraction as a decimal, we can only have 2 digits after the decimal point. We can't go beyond the hundredths place value column. So 54 hundredths is written as 0.54. The denominator of 100 tells us that we can't go beyond the hundredths. We can only have 2 digits after the decimal point, and that means the 5 gets pushed over into the tenths column. Now we have 54 thousandths. The denominator of 1,000 tells us that we can only have 3 digits after the decimal point, so that's 0.054. Because we can't go past the thousandths column, the 5 gets pushed over into the hundredths, but we need 0 in our tenths and 0 in our ones. Finally, we have 543 thousandths. Again, the denominator of 1,000 tells us that we can only have 3 digits after the decimal point, so that's 0.543. So the 4 gets pushed over into the hundredths column, and the 5 gets pushed over into the tenths column. Now let's take a closer look at some of these questions. For 3 thousandths, that's 0.003, because the first digit is the tenths, then the hundredths, but we want to show that we have 3 thousandths, so we need zeros in our tenths and hundredths to make it clear that this 3 is the third digit after the decimal point. Now let's take a closer look at 54 thousandths. That was 0.054, but here you'll notice that the 5 is written in our hundredths column, and only the 4 is in our thousandths. 5 hundredths is equivalent to 50 thousandths. That's because we use multiplication to find equivalent fractions. 100 times 10 is 1,000, and what we do to the denominator, we do to the numerator as well, and 5 times 10 is 50. So then we can add the 4 thousandths, and we have a common denominator. So the denominator stays the same in our answer, and 50 plus 4 is 54. And that's why we can write 54 thousandths as a decimal with 5 in our hundredths place value column. Then we had 543 thousandths, which is 0.543. So as a decimal, that's written with 5 in our tenths column, 4 in our hundredths column, and 3 in our thousandths column. But 5 tenths is equivalent to 500 thousandths. That's because we can use multiplication to find equivalent fractions. 10 times 100 is 1,000, and what we do to the denominator, we do to the numerator as well, and 5 times 100 is 500. Now, instead of adding 4 hundredths, we can add 40 thousandths. These fractions are equivalent because 100 times 10 is 1,000, and 4 times 10 is 40. So now we can add the 3 thousandths, the 3 that's in our thousandths column, because we now have denominators that are the same. So the denominator stays the same in our answer, and 500 plus 40 plus 3 is 543. So that's why we can write this fraction as a decimal with 5 in our tenths, 4 in our hundredths, and 3 in our thousandths. Let's just take one closer look at this middle question, 54 thousandths. We can show that here, but we know that 10 thousandths is the same as 100th. So we can write that as 0.054 because if we join 10 thousandths together to make a hundredth, we now have 5 hundredths and 4 thousandths, so 0.054, because the second digit after the decimal point is our hundredths digit, and the third digit is our thousandths digit. So here we have 700 thousandths. We're going to find equivalent fractions with a denominator of 100 and 10, and then we're going to write 700 thousandths as a decimal. So, to find out how many hundredths that's equivalent to, we can use division. 1000 divided by 10 is 100, and when we're finding equivalent fractions, what we do to the denominator, we do to the numerator as well, and 700 divided by 10 is 70. So 700 thousandths is equivalent to 70 hundredths. Now let's find an equivalent fraction with a denominator of 10. 100 divided by 10 is 10, and 70 divided by 10 is 7. So that's equivalent to 7/10. So let's think about how we write this as a decimal. We can write 700 thousandths as 0.700, because the denominator of 1,000 says there'll be 3 digits after the decimal point, and we have 700, so the 7 needs to be shifted over to the tenths. But remember, 700 thousandths is the same as 70 hundredths, and we can write that as 0.70. The denominator of 100 tells us that we can use place values up to the hundredths place, so have 2 digits after the decimal point, and we have 70, so the 7 gets shifted over to the tenths. But that's equivalent to 7/10, which we just write as 0.7. So it's important to understand that because these fractions are equivalent, if we have zeros on the end of a decimal, we don't need to write them. That's because here, for example, 700 thousandths is equivalent to 7/10, and if you have zeros on the end of a decimal, it's always equivalent to a fraction with a smaller denominator. Now we have 70 thousandths. We need to find how many hundredths is that. Well, to get equivalent fractions, we can use division. So 1000 divided by 10 is 100, and 70 divided by 10 is 7. So 70 thousandths is equivalent to 7 hundredths. And let's think about how we write that as a decimal. If we're writing 70 thousandths, the denominator of 1,000 tells us that we can't go past the thousandths place, so we can have 3 digits after the decimal point. Because we have 70, the 7 gets shifted over into the hundredths place. But 70 thousandths is equivalent to 7 hundredths, and we write that as 0.07, because the second digit after the decimal point is the hundredths digit. So again, you can see that we don't need zeros on the end of decimals, because if we have zeros on the end of decimals, they're always equivalent to fractions which have a smaller denominator. So for this first question, we started with 700 thousandths, but we saw that that was equivalent to 70 hundredths. So here we've shown 70 hundredths place value counters. But remember, 10 hundredths can be exchanged for 1/10. So 70 hundredths is equivalent to 7/10, and that's why we can write it as 0.7. Then for the second question, we had 70 thousandths, so here we've shown 70 thousandths counters. But remember, 10 thousandths can be exchanged for 1 hundredth. So that's why 70 thousandths is equivalent to 7 hundredths, so can just be written as 0.07 without needing the 0 on the end. We need to partition these numbers into tenths, hundredths and thousandths. So first we have 0.158. and we can show the partitioning in both fraction and in decimal form. So the first digit after the decimal point is the tenths digit, so we have 1/10. Then the second digit after the decimal point is the hundredths digit, so that's 5/100ths, and the third digit after the decimal point tells us how many thousandths we have, so we have 8/1000ths. We can show this partition in decimal form as well. That's 0.1 plus 0.05 plus 0.008, because the first digit after the decimal point is the tenths, and we have 1/10. The second digit after the decimal point is the hundredths, and we have 5/100ths, and the third digit is the thousandths, and we have 8/1000ths. So now we have 0.629. The first digit is the tenths, so that's 6/10ths. The second digit is the hundredths, so that's 2/100ths. And the third digit is the thousandths, so that's 9/1000ths. In decimal form, we can write this as 0.6 because the first digit is the tenths digit, plus 0.02 because the second digit is the hundredths digit, plus 0.009 because the third digit after the decimal point is the thousandths digit. We can also show the decimal partition as a column addition. So for 0.158, we had 0.1 plus 0.05 plus 0.008. Now we can write these numbers out with the decimal points lined up, because if the decimal points are lined up, then the other place values, so the ones, tenths, hundredths and thousandths columns, will be lined up as well. Now, when we're adding decimals, we can write zeros in empty squares, because 0.100 is the same as 0.1. All these zeros tells us is that we don't have any extra hundredths or thousandths, and we can write a 0 in this empty square as well. So now we copied the decimal point down into our answer so that the place values in our answer are lined up as well. And now 0 plus 0 plus 8 is 8, 0 plus 5 plus 0 is 5, 1 plus 0 plus 0 is 1, 0 plus 0 plus 0 is 0. And you can see that when we add the partitioned numbers, we get the number that we started with. For 0.629, we saw that that was 0.6 plus 0.02 plus 0.009. So again, we can write the numbers out with the decimal points lined up so that our place values are lined up as well. We can write zeros in empty squares, and then the decimal point needs to be written in our answer. We can add each column using column addition, and that gives us 0.629, so the number that we started with. Let's have another look at this first question. 0.158 is 1/10, 5/100ths and 8/1000ths, so we can show the partition using place value counters as well. And for 0.629, we had 6/10ths, 2/100ths and 9/1000ths. We need to write these decimals as mixed numbers. So first, we have 5.4. Remember, the digit before the decimal point is the ones digit, so that tells us how many ones or wholes we have, and then the digit after the decimal point is the tenths digit. So if we have one digit after the decimal point, what we can do is draw a line across from the decimal point and write a denominator of 10. So 5.4 is 5 4/10ths as a mixed number. Now we have 5.04. Remember, the second digit after the decimal point is the hundredths digit. So if we have two digits after a decimal point, what we can do is draw a line across from the decimal point and write a denominator of 100. So 5.04 is the same as 5 4/100ths. Now 5.004. The third digit after the decimal point is the thousandths digit. So if we have 3 digits after the decimal point, we can draw a line across from our decimal point and write a denominator of 1,000. So 5.004 is the same as 5 and 4 thousandths. So notice, when there was 1 digit after the decimal point, we drew a line across with a denominator of 10, so 10. When there were 2 digits after the decimal point, the denominator was 100, so 2 zeros. And when there were 3 digits after the decimal point, we drew a line across and our denominator was 1,000, so 3 zeros. Now we have 6.24. There's 2 digits after the decimal point, so we can draw a line across and write a denominator of 100, so 2 zeros. So 6.24 is 6 and 24 hundredths. Now 7.024. There are 3 digits after the decimal point, so we can draw a line across and write a denominator of 1,000, so 3 zeros. That means 7.024 is 7 and 24 thousandths. We're ignoring the zeros on the start when we write our numerator, because we don't have zeros at the start of whole numbers. And though our numerator isn't really a whole number, we don't need to write 7 and 024 over 1,000. We can just write 7 and 24 over 1,000. Finally, we have 7.124. Again, there's 3 digits after the decimal point. We know the third digit is the thousandths digit, so we can draw a line across from our decimal point and write a denominator of 1,000. So that's 7 and 124 thousandths. Let's take a closer look at some of these questions. So we had 7.024. Because there were 3 digits after the decimal point and our third digit after the decimal point is the thousandths digit, we wrote a denominator of 1,000, so got 7 and 24 thousandths. We can see why this works if we think about the place values in the number 7.024. That's 7 wholes, we don't have any tenths, we have 2 in our hundredths and 4 in our thousandths. Now the 7 wholes can stay the same, but instead of writing 2 hundredths, we can write 20 thousandths. These fractions are equivalent because we can use multiplication to find equivalent fractions, and 100 times 10 is 1,000. What we do to the denominator, we do to the numerator as well, and 2 times 10 is 20. So then, if we add the 4 thousandths, we still have 7 wholes, but we have a common denominator. So that stays the same in our answer, and 20 plus 4 is 24. So that's why we can write 7.024 as 7 and 24 thousandths. It's because the 2 in our hundredths is equivalent to 20 thousandths, and putting that together with the 4 thousandths gives us 24 thousandths in our mixed number. Then we had 7.124. So again, let's think about the place values. We have 7 ones, 1/10, 2 hundredths, and 4 thousandths. So the 7 can stay the same, but 1/10 is equivalent to 100 thousandths. That's because 10 times 100 is 1,000, and 1 times 100 is 100. Then, instead of 2 hundredths, we can think of that as being 20 thousandths. They're equivalent because 100 times 10 is 1,000, and what we do to the denominator, we do to the numerator, and 2 times 10 is 20. So we can add our 4 thousandths, and that gives us 7 wholes, but now we have a common denominator. So that stays the same in our mixed number, and 100 plus 20 plus 4 is 124. So we can write 7.124 as 7 and 124 thousandths, because 1/10 is equivalent to 100 thousandths, and 2 hundredths is equivalent to 20 thousandths, and when we put those together with our 4 thousandths, we get 124 thousandths. So let's take a closer look at 7.024. That's 7 ones, 0 tenths, 2 hundredths and 4 thousandths. But that's the same as 7 and 24 thousandths, because remember, each of these hundredths can be exchanged for 10 thousandths, so that gives us 24 thousandths in our mixed number. And let's look at 7.124. That's 7 ones, 1 tenth, 2 hundredths and 4 thousandths. How is that equivalent to 124 thousandths? Well, what we can do is exchange 1 tenth for 10 hundredths. That gives us 12 hundredths, but we can exchange each of these hundredths for 10 thousandths, and when we do that with all 12 of our hundredths, that gives us 124 hundredths altogether. We need to write these mixed numbers as decimals. First, we have 1 and 2 tenths. That's 1.2, because the digit before the decimal point is the ones digit, so tells us how many wholes we have, and the digit after the decimal point is the tenths digit, and we have 2 tenths. Now, 1 and 2 hundredths is written as 1.02. That's because the second digit after the decimal point is the hundredths digit, and we have 2 hundredths. That means we need a 0 in our tenths to make it clear that we're writing the 2 in the hundredths place value column. Now, 1 and 2 thousandths is 1.002. That's because the third digit after the decimal point is the thousandths digit, and we need to show that we have 2 thousandths, so we need zeros in our tenths and hundredths. Notice the denominator of 10 tells us that there will be 1 digit after the decimal point, because the first decimal place value is the tenths. The denominator of 100 tells us that there will be 2 digits, because the second decimal place value is the hundredths. And when we have a denominator of 1,000, we need 3 digits after the decimal point, because the third decimal place value is the thousandths. So now we have 4 and 32 hundredths. The denominator of 100 tells us that we can only use 2 digits after the decimal point. So that's 4.32. The 3 gets pushed over into the tenths, because the denominator of 1,000 tells us that we can't go beyond the thousandths place value, so we can only have 2 digits after the decimal point. Now, 5 and 32 thousandths. The denominator of 1,000 tells us that this time we can only have 3 digits after the decimal point. So we write 5 and 32 thousandths as 5.032, because then we have 3 digits after the decimal point, so we're not going beyond our thousandths place value, but the 3 gets pushed over into the hundredths place. Finally, we have 6 and 321 thousandths. That's 6.321. The denominator of 1,000 tells us that we can't go beyond the thousandths place value, so we can only have 3 digits after the decimal point. That means the 2 gets pushed over into the hundredths, and the 3 gets pushed all the way over into the tenths. So notice, when the denominator is 10, that's 1 0, so when we write the number, we have 1 digit after the decimal point. When we have a denominator of 100, that's 2 zeros, so we have 2 digits after the decimal point. And when we have a denominator of 1,000, that's 3 zeros, so we have 3 digits after the decimal point. Now let's take a closer look at these last 2 questions. We had 5 and 32 thousandths. That's 5.032. If we break down this number into its place values, we have 5 wholes, no tenths, 300ths, and 2 thousandths. So how does that give us 5 and 32 thousandths? Well, the 5 stays the same, but 300ths is equivalent to 30 thousandths. That's because we use multiplication to find equivalent fractions. 100 times 10 is 1,000, and what we do to the denominator, we do to the numerator as well, and 3 times 10 is 30. So we can add the 2 thousandths to that, so our whole number stays the same. We have a common denominator of 1,000, so that stays the same in our mixed number, and 30 plus 2 is 32. So that's why 5 and 32 thousandths is equal to 5.032. It's because 30 thousandths is the same as 300ths. Then we had 6 and 321 thousandths, and that was equal to 6.321. If we break down this number by its place values, we have 6 ones, 3 tenths, 2 hundredths, and 1 thousandth. The 6 can stay the same, but instead of 3 tenths, we can write 300 thousandths, because 10 times 100 is 1,000, and if we do the same to the numerator, 3 times 100 is 300. Then, instead of adding 2 hundredths, we can add 20 thousandths. That's equivalent because 100 times 10 is 1,000, and 2 times 10 is 20. And then we add 1 thousandth. So the 6 stays the same. We have a common denominator of 1,000, and 300 plus 20 plus 1 is 321. So that's why 6 and 321 thousandths can be written as 6.321. It's because 300 thousandths is the same as 3 tenths, 20 thousandths is the same as 2 hundredths, and then putting that together with the 1 thousandth gives us 6.321. Let's just have one more look at this question, 5 and 32 thousandths. That's 5.032, because remember 10 thousandths can be exchanged for 1 hundredth, and when we do that with 30 of our thousandths, we have 5 ones still, but now we have 3 hundredths and 2 thousandths, so 5.032. So here we have a place value chart, and we count place values from the decimal point. So our whole number place values are our ones, tens, hundreds, thousands, 10,000s and 100,000s, and our decimal place values are our tenths, hundredths and thousandths. So if we just have 3 ones, normally what we just write as the number 3, really we have invisible zeros in all of our other place value columns, and an invisible decimal point on the end of every whole number. But we don't need zeros at the start of a whole number, and we don't need zeros in our decimal place values if we only have 3 ones. And though there's really an invisible decimal point on the end of every whole number, we don't write the decimal point when we're writing whole numbers. Now, what if we just have 3 tenths? All of our other place value columns are really zeros, but we don't need zeros in our whole number place values if we only have 3 tenths. The exception is our ones column. We always need to write a digit in the ones place value, so here we do need to write the 0. But we don't need zeros on the end of decimals. All this 0 here tells us is that we don't have any thousandths, and this 0 just tells us that we don't have any hundredths. But just writing 0.3 tells us this as well, because in 0.3 that tells us that we only have 3 tenths. What if we have 3 hundredths? All of our other place values are really zeros, but we don't need zeros in our whole number place value columns except for our ones column, And we don't need zeros on the end of decimals because all this zero here tells us is that we don't have any extra thousandths. But we do need this zero in our tenths. That's because we need to show 3 hundredths, and our hundredths place value column is always the second place value column after the decimal point. So if we didn't have 0 in our tenths, the 3 would be in our tenths, but we need to show 3 hundredths, so that has to be the second digit after the decimal point. Now, what if we have 3 tens and 3 hundredths? All of our other place values are really zeros, but we don't need zeros on the start of a whole number, and we don't need zeros on the end of decimals. But we do need this 0 here because we need to show that this 3 stands for 3 tens. So we need a 0 in our ones because we count whole number place values from the decimal point, and the tens place value is always the second digit before the decimal point. We also need this 0 in our tenths, just as we did here, so that the 3 is in our hundredths column, so it's the second digit after the decimal point. Now, what if we have 3 thousandths, 3 tens, 3 tenths, and 3 thousandths? We really have 0 in all of our other place values, but this time the only zeros that we don't need are these zeros at the start of our number. We need this 0 here because without it, the 3 would be in our hundredths column, and we need to show 3 thousandths. We also need all of our other zeros. So if we didn't have this 0, then the 3 that's in our thousandths would be in our hundredths. But the thousandths digit is always the third digit after the decimal point, so we need 0 in our hundredths. So this 0 and these other zeros that we have are called placeholders. They don't have any value in themselves, but they give the other digits value. They make sure that the other digits are in the right place value columns, so that's why they're called placeholders. Now let's count in thousandths. So first we have 0.623, so that's 6 tenths, 2 hundredths, and 3 thousandths. If we count in thousandths, we then have 0.624, then 0.625. What are the next 7 numbers in this sequence? Well, if we show them, you can see that counting in thousandths is similar to counting in ones. The only thing we need to change is 0.630. That's usually just written as 0.63 because we don't need zeros on the end of decimals. And to see why not, let's count using the place value counters. So we can keep on counting in thousandths until we have 10 thousandths. But when we get 10 thousandths, we can exchange those for 1 hundredth, because 1 hundredth is the same size as 10 thousandths. But now you can see that we have 6 tenths, 3 hundredths, and no thousandths. So rather than writing 0.630, we don't need to write the 0 in our thousandths, because 0.63 also tells us that we only have 6 tenths and 3 hundredths with no extra thousandths. Then we kept on counting in thousandths until we got to 0.632, so 6 tenths, 3 hundredths, and 2 thousandths. Now we start with 0.795, so 7 tenths, 9 hundredths, and 5 thousandths. Next, we'll count 0.796, 0.797, and what are the next 7 numbers in this sequence? Well, we're counting in thousandths, and that's similar to counting in ones, except that when we get zeros on the end of decimals, we don't need to write them. 0.8 is the same as 0.800. And to see why, let's again count using the place value counters. So we started with 0.795, which we can see here. If we keep on adding thousandths counters until we get to 10 thousandths, we can then exchange those 10 thousandths counters for one hundredth counter. So that means we have 7 tenths and 10 hundredths. But remember, if we've got 10 hundredths counters, we can exchange those for 1/10th counter, because 1/10th is the same size as 10 hundredths. So then we just have 8 tenths counters, so that's why we can just write 0.8. Then we can keep on counting in thousandths, but we need to make sure that we write 0.801, because remember, we're counting in thousandths, not in hundredths. We keep on counting until we get to 0.804, so that's 8 tenths, no hundredths, and 4 thousandths. Now we start with 2.593, so that's 2 wholes, 5 tenths, 9 hundredths, and 3 thousandths. What will the next numbers in this sequence be? Well, we can show them, and again there's one value that we need to change, because we don't need to write zeros on the end of decimals. So if we're counting in thousandths, we go from 2.599 to 2.6, then to 2.601. And again, we can use place value counters to explain that. If we keep on counting in thousandths until we get 10 thousandths, we can exchange those 10 thousandths for 1/100th. But now, doing that means that we have 10 hundredths counters, and 10 hundredths is the same as 1/10th. So now we have 2 wholes and 6 tenths, or 2.6. Then we keep on counting in thousandths, so we need to make sure that we have this 0 in our hundredths, and in the end we got to 2.602, so 2 wholes, 6 tenths, no hundredths, and 2 thousandths. Finally, we have 1.995, so 1 whole, 9 tenths, 9 hundredths, and 5 thousandths. If we complete the sequence, you can see that we get 2.000, but if you have a decimal point and then zeros on the end of a number, you have a whole number, so 2.000 is just the number 2. And we can see that again if we count using the place value counters. We started with 1 whole, 9 tenths, 9 hundredths, and 5 thousandths. We kept on adding thousandths, but then when we got to 10 thousandths, we had something that's the same as 2 wholes. To see that, spot that if we have 10 thousandths, we can exchange those 10 counters for 1/100th counter. But now we have 10 hundredths counters, and we can exchange those for 1/10th, because 1/10th is the same as 10 hundredths. But now we have 10 tenth counters, and 10 tenths is the same as 1 whole. So that's why we have 2 wholes altogether now. Notice we were just exchanging here. We were just exchanging 10 of one place value for 1 of the place value to the left, and we did that 3 times, so that's why after 1.999, when we added just 1 more thousandth counter, we got 2 wholes. Then we can keep on counting in thousandths until we get to 2.004, so that's 2 wholes and 4 thousandths. And it's important that we remember to write zeros in our tenths and hundredths, because we're counting in thousandths, and the thousandths digit always has to be the 3rd digit after the decimal point. Now let's practice counting back in thousandths. So to start, we have 0.537, so we can show that with 5 tenths, 3 hundredths, and 7 thousandths. If we're counting back in thousandths, we then have 0.536, then 0.535. What are the next 7 numbers in this sequence? Well, if we show them, we can see that counting back in thousandths is similar to counting back in ones. the only value that we need to change is 0.530 because we don't usually write zeros on the end of decimal numbers. So 0.530 can just be written as 0.53 because all the 0 on the end tells us is that we don't have any extra thousandths, but 0.53 tells us this as well. It's also important to notice that 0.529 is smaller than 0.53. In fact, it's 1,000th smaller because we're counting back in thousandths. So let's show the counting using place value counters. We start with 5/10ths, 300ths and 7,000ths, so that's 0.537. We can keep on subtracting thousandths, but when we get to 0.53, so 5/10ths and 300ths, we need to exchange one of our hundredths for 10,000ths so that we can continue subtracting thousandths until we get to our last value 0.528, so that's 5/10ths, 200ths and 8,000ths. Now we start with 0.905, so that's 9/10ths, no hundredths and 5,000ths. If we count back in thousandths, we have 0.904, 0.903, and then you can see how we can complete the sequence. So counting back in thousandths is similar to counting back in ones, but we get 0.900, and we don't need to write zeros on the end of whole numbers because 0.9 is the same as 0.900. So we can see what we're doing is taking away thousandths. But then when we get to 0.9, so 9/10ths, we need to exchange one of our tenths for 10 hundredths. But because we want to count back in thousandths, we can take one of our hundredths and exchange it for 10 thousandths. So now we can continue counting back in thousandths, so 0.899 is 1,000th less than 0.9, and we can continue subtracting thousandths until we get to 0.896, so that's 8/10ths, 9 hundredths and 6 thousandths. Now 3.507, 3.506, 3.505. What are the following numbers in this sequence? Well, we're counting back in thousandths, and that's similar to counting back in ones, except that we get 3.500, and we don't write zeros on the end of decimals because 3.500 is the same as 3.5. So notice the pattern goes 3.501. If we take away 1,000th, we get 3.5. Then, if we take away 1,000th from that, we get 3.499. And we can use place value counters to explain this. So we start with 3.507, so that's 3 ones, 5/10ths, no hundredths, and 7 thousandths. If we're counting back in thousandths, we're taking away 1,000th each time. So here we've got 3 ones and 5/10ths, so that's 3.5. What we can do is take one of our tenths and exchange it for 10 hundredths. But we're taking away 1,000th at a time. So what we need to do now is take one of our hundredths and exchange it for 10 thousandths. So now that we've exchanged and exchanged again, we can take away one of our thousandth, and we can see that that's 3.499 because we have 3 ones, 4 tenths, 9 hundredths and 9 thousandth. So we just need to take away one more thousandth to leave us with 3.498. Finally, we start with 1.005, so that's 1 whole, no tenths, no hundredths and 5 thousandths, because the third digit after the decimal point tells us how many thousandths we have. Then, if we're counting back in thousandths, we get 1.004, 1.003, and what 7 numbers come next? Well, we can show them here, and we can see counting back in thousandths is similar to counting back in ones. But you'll notice we have 1.000. Now, if we have a decimal point and then zeros on the end of a number, we have a whole number. All the 0.000 tells us is that we don't have any tenths, hundredths or thousandths, but just writing the whole number 1 tells us this as well. So again, let's use place value counters so that we can see what we did here. We're counting back in thousandths, so taking away one of our thousandths counters each time. But now, when we have one whole, in order to subtract thousandths, we first need to exchange that one whole for 10 tenths, because 10 tenths is the same as one whole. Then we can take one of our tenths and exchange it for 10 hundredths, because 10 hundredths is the same as 1 tenth. And finally, we can exchange again, taking one of our hundredths and exchanging that counter for 10 thousandths counters. So now we can keep on taking away thousandths until we get to 0.996, so that's 9 tenths, 9 hundredths and 6 thousandths. So here we have a number line with 0.42, 0.43 and 0.44 labelled. So the labelled values are going up in hundredths, but to get from 100th to the next, notice that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 small lines, and 10 thousandths is the same as 100th, so these small lines must be thousandths. So what number is the arrow pointing to here? Well, it's 3 lines, so 3 thousandths after 0.42, so that's 0.423. Now we have 1 thousandth after 0.43, so that's 0.431. Now we have 5 thousandths after 0.43, so that's 0.435. And finally, we have 0.438. And notice 0.438 is less than 0.44. To understand why that is, what I like to do when I see decimals on number lines is to add a 0 on the end of the labelled values. So instead of 0.42, we can write 0.420, and then we can also put a 0 on the end of 0.43 and 0.44, because remember, putting a 0 on the end of a decimal doesn't change the number, but it does make it easier to see the values that we labelled. So here we had 0.423, then 0.431, 0.435 and 0.438, and if we remember that 0.44 is the same as 0.440, then it's easier to understand why 0.438 is less than 0.44. In fact, we can see that it's 2 thousandths less. So now we have a number line with 0.99, 1 and 1.01 labelled. Now 1 is 100th more than 0.99 and 1.01 is 100th more than 1. So the values we have labelled again are going up in hundredths, which means the small lines in between what we have labelled must be thousandths, because remember, 10 thousandths is the same as 100th. So here the arrow is pointing 4 thousandths after 0.99, so that's 0.994. Here we have 1 thousandth after 1, so that's 1.001, because the third digit after the decimal point is the thousandths digit, and each of these small lines represents 1 thousandths. So we need 0 in our tenths and hundredths to show that this 1 is 1,000th. Now we have 1.004, so 1 whole and 4 thousandths. And finally, we have 1.009. So notice 1.009 is 1,000th less than 1.01. And it's easier to see if we write zeros on the end of our decimals so that they have 3 decimal places. Instead of 0.99, we can write 0.990 because putting a 0 on the end of a decimal doesn't change the number. Now for 1, we can also write the number 1 with 3 decimal places. That's 1.000 because we can always put a decimal point and then zeros on the end of a whole number, and that doesn't change the number. Finally, 1.01 can be written as 1.010. So when decimals are labelled on a number line, it's useful to write them all with the same number of decimal places, and that makes it easier to identify values on the number line. So first, we had to identify that this was 0.994, then we had 1.001, then 1.004, and then 1.009. So because all of the decimals that we have labelled have 3 decimal places, you can see that putting these values on the number line isn't any more difficult than if we had a number line with 990, 1000 and 1010 labelled. Now for this number line, we have 2.1, 2.11 and 2.12. Again, the values that we have labelled are going up in hundredths, which means the small lines in between the hundredths must be thousandths. So here we have 3 thousandths after 2.1. That's 2.103, and it's really important that we remember the 0 in our hundredths, because these lines are thousandths, and to show 3 thousandths, we need to write the thousandths digit as the 3rd digit after the decimal point. So we need a 0 in our hundredths digit. If we wrote 2.13, that wouldn't make sense, because you can see that after the value we need to label, we have 2.11, then 2.12. So 2.13 would be the next labelled value if we continued the same number line. So we need 2.103. So here we have 2.109, and notice that that's 1,000th less than 2.11. Here we have 2.113 because that's 3 thousandths after 2.11, and here we have 2.119. Again, what we could have done was change the labelled values so that they all have 3 decimal places. So instead of 2.1, we can write 2.100, because putting zeros on the end of a decimal number doesn't change the value of that number. For 2.11, we could have written 2.110, so again, we've got 3 digits after the decimal point, and then we could have put a 0 on the end of 2.12. So now, if we look at the values that we had to label, here we had 2.103, here 2.109, and if we spot that 2.11 is the same as 2.110, it makes sense that 2.109 is 1,000th less than 2.11. Here we had 2.113, and finally our last value was 2.119. Now we need to compare decimals. First, we have 5.298 and 5.289. The way that we compare decimals is to write both numbers out, one below the other, with the decimal points lined up, because if the decimal points are lined up, then the place values, so the ones, tenths, hundredths and thousandths digits will be lined up as well. Now we start by comparing the largest place values, so we work from left to right. Both numbers have 5 in the ones, so we go across to the tenths, but they both also have the same number of tenths. So we go on to the next place value column, so on to the hundredths. Now we can see that the first number has 9 hundredths and the second number only has 8. So 5.298 must be larger than 5.289. So now that we've seen that this number, the first number, has more hundredths, we don't need to look at the thousandths, because we need 10 thousandths in order to make something that's the same size as just 1 hundredth. Now we have 34.2 and 30.993. So our decimal points are lined up, which means our place values are lined up as well. And sometimes it's easier if we have empty squares, like we have here, to write zeros in those empty squares. Now we start by comparing the larger place values, which here is our tens, and both numbers have 3 tens. So we go to the next place value to the right, and the first number has 4 in the ones, and the second number has 0. So we know that 34.2 must be larger than 30.993. So sometimes when we're comparing decimals, all we need to do is to compare what comes before the decimal point. So here we had 34 and 30, because remember, anything that comes after the decimal point is less than 1 whole. Now we have 1.405 and 1.44. Our decimal points are lined up, which means our ones, tenths, hundredths and thousandths digits are lined up as well. We can write a 0 in this empty square, and now we start by comparing the larger place values, which here is our ones. Both numbers have 1 in the ones column and 4 in the tenths column, so we need to go across to the hundredths. The first number has 0 in the hundredths, but the second number has 4. So 1.405 is less than 1.44. That might be confusing because 1.405 uses more digits, and with whole numbers, numbers with more digits are larger. But remember, we can put zeros on the end of decimals. 1.440 is the same as 1.44. All this 0 tells us is that we don't have any thousandths in this number. And if you put zeros on the end of decimals so that you're comparing decimals with the same number of decimal places, it's much easier to see which is larger. Because we know that 1440 is larger than 1405, we know that 1.44 must be larger than 1.405. Finally, we have 2.9 and 2.099. Our decimal points are lined up. We can write zeros in empty squares, and we start by comparing the largest place value. Both of these numbers have 2 in the ones, so we go across to the tenths. And with this first number, we have 9 in the tenths, but with the second number, we have 0. So, because 9 is larger than 0, we know straight away that 2.9 must be larger than 2.099. It doesn't matter that the second number has more hundredths and more thousandths, because even 9 hundredths and 9 thousandths together is less than 1/10. Let's have a look at the numbers that we were comparing. First, we had 5.298, so that's 5 ones, 2 tenths, 9 hundredths and 8 thousandths, and we were comparing that to 5.289, so 5 ones, 2 tenths, 8 hundredths and 9 thousandths. This first number was larger because it has 9 tenths, but the second number only has 8 tenths. Then we had 34.2 and 30.993. Now even though this second number has more place value counters, it's not as large as the first number, because remember, ones are larger than anything that comes after it. So even all of these counters together add up to less than one whole. Then we had 1.405 and 1.44. 1.44 is larger because remember, we need 10 thousandths counters to have something that's the same as just 1/100th, and this number has 4 hundredths. Finally, we had 2.9 and 2.099. 2.9 is larger because it has 9 tenths and 2.099 doesn't have any tenths. Even all of these counters taken together add up to less than 1/10. That's because we need 10 thousandths counters to make 1/100th, and we need 10 hundredths counters to make just 1/10. We need to write the numbers below in order from smallest to largest. So here we're ordering decimals, and the easiest way to order decimals is to write out the numbers one below the other with the decimal points lined up. So we have 0.34, 0.3, 0.403, 0.344, and 0.43. So we've written the numbers out one below the other, and we've got the decimal points lined up. And that's important because if our decimal points are lined up, then all the other place values will be lined up as well. So we have a column for our ones, tenths, hundredths, and thousandths. Now the other thing to remember about ordering decimals is that we can write zeros on the end of decimals without changing the value of the number. So instead of 0.34, we can write 0.340. All this zero tells us is that we don't have any extra thousandths, so we haven't changed the number, but that makes it easier for us to compare. So instead of 0.3, we can have 0.300, and instead of 0.43, we can write 0.430. So now, all of our numbers have the same number of digits, and that means that we can compare them in the same way as we would compare whole numbers if we had 340, 300, 403, 344, and 430. So our smallest decimal is 0.3, then we have 0.34, then 0.344, 0.403, and our largest decimal is 0.43. So when we're writing the decimals in the answer boxes, it's best to write them in the same way that they're presented in the question, so without the zeros on the end. But putting the zeros on the end is important, because normally, if we have whole numbers, numbers with more digits are larger than numbers with fewer digits. But with decimals, what we need to do is write zeros on the end of decimals so that all of the decimals we're comparing have the same number of digits. Now we need to compare 4, 3.94, so we're writing that with the 3 ones underneath the 4 ones, 4.03, 4.004, and 3.499. Now again, we've got our decimal points lined up, but with the number 4, we have a whole number. Now whenever we have a whole number, we can write a decimal point and then zeros on the end without changing the number. 4.000 is the same as 4, because all the zeros tell us is that we don't have any extra tenths, hundredths, or thousandths. So we can write 0 in these empty squares as well. And now, because the decimals have the same number of digits, we can compare them in the same way as we would compare whole numbers. So our smallest decimal is 3.499, because if we ignore the decimal point, that's like 3,499. Then we have 3.94, because if we ignored the decimal point, That's similar to 3,940. Then we have the number 4, which if we ignored the decimal point would be 4,000. Then we have 4.004, because if we ignored the decimal point, that would be 4004. And then our largest decimal is 4.03, because if we ignore the decimal point, that's like 4030. Now here, to make sure we're not confused, I've talked about ignoring the decimal point, but it's important to understand that 4.030 or 4.03 is not the same as 4030. In fact, it's 1,000 times smaller. But this method works because we can write zeros on the end of decimals so that they have the same number of digits. That means we can compare them in the same way that we would compare whole numbers. Now we need to add numbers with a different number of decimal places. So first we have 5.87 plus 3.123. We can use column addition for this, but it's really important that we remember that the decimal points need to be lined up, so we don't line up the digits on the right hand side like we do when we're adding whole numbers. When we're adding decimals, we need to make sure that it's the decimal points that are lined up. That way, our ones, tenths, hundredths and thousandths digits will be lined up as well. Now, 5.87 is the same as 5.870, so we can write zeros in empty squares, because that doesn't change the value of the number. All this zero tells us is that we don't have any thousandths in the number 5.87. So now we've got our decimal points lined up, we've written 0 in our empty square, so we copy the decimal point down into our answer so that the place values are lined up in our answer as well, and now we just add using column addition. 0 plus 3 is 3, 7 plus 2 is 9, 8 plus 1 is 9, and 5 plus 3 is 8. So our answer is 8.993. Now we have 19.36 plus 35.816. Again, we've written the numbers out with the decimal points lined up, so that the other place values in our question are lined up as well. Now we can write a 0 in this empty square, and it's really important that we remember to copy the decimal point down into our answer, and I like to do this first so that I don't forget. Now 0 plus 6 is 6, 6 plus 1 is 7, 3 plus 8 is 11, so that's 1, 1, with the first digit above the next place value column along, which here is our ones column. Now 1 plus 9 plus 5 is 15, so that's 1, 5, and 1 plus 1 plus 3 is 5, so that gives us 55.176. Finally, we have 5.871 plus 3.2. We've written the numbers out with the decimal points lined up, and we can write zeros in these empty squares because 3.200 is the same value as 3.2. All the zeros tell us is that we don't have any hundredths or thousandths in the number 3.2. So now we can copy the decimal point down into our answer and add using column addition. So 1 plus 0 is 1, 7 plus 0 is 7, 8 plus 2 is 10, so that's 1, 0, with the first digit written above the next place value column along, which here is our ones column. And now 1 plus 5 plus 3 is 9, so that gives us 9.071. Now let's have a look at this first question, and let's show place value counters so we can see what we did. We started with 5.87, so that's 5 ones, 8 tenths, and 7 hundredths. First, we added 3 thousandths, so we can add 1, 2, 3 thousandths, and that gives us 3 thousandths in our answer. Then we added 2 hundredths to give us 9 hundredths in our answer. Then we added 1 tenth, to give us 9/10, and finally we added 3 ones to give us 8 ones in our answer. Then we started with 19.36, so that's 1/10, 9 ones, 3 tenths and 6 hundredths. First we added 6 thousandths, and because we didn't start with any thousandths, that left us with 6 thousandths in our answer. Then we added 1 hundredth to give us 7 hundredths in our answer. Then we added 8 tenths, but because that gave us 11 tenths, we exchanged 10 of those tenths for 1 whole, and we were left with just 1/10 in our answer. You can see if we add 8 tenths, that's 1, 2, 3, 4, 5, 6, 7, 8, you can see that when we got to 10 tenths, we exchanged those 10 tenths counters for 1 whole, and then that was added to our ones column. So that's why when we write the column method, we can write 1 above the ones column, because we've made this extra 1 from adding our tenths. But adding the 8 tenths, as well as giving us 1 whole, also gave us 1/10 to write in our answer. Now, onto our ones column, we had 1 plus 9 plus 5. But adding the 1 that we've made from adding our tenths to the 9 ones that we started with gives us 10 ones, which we can exchange, and then we just need to add 5 ones to give us 5 ones in our answer. Finally, in our tens column, we needed to add the 1 that we made from adding our ones to the 1/10 that we started with, and then add 3 more tens to give us 5 tens in our answer, 55.176. Finally, we started with 5.871, so that's 5 ones, 8 tenths, 7 hundredths and 1 thousandth. We weren't adding any thousandths or any hundredths, so the 1,000th and 7 hundredths stayed the same in our answer. But then we added 2 tenths, and that meant that we had 10 tenths altogether, so could exchange them for 1 extra 1. So that meant we had 0 tenths in our answer. And then onto the ones column, we had the 1 that we made, plus the 5 that we started with, plus another 3. So that gave us 9 tenths in our answer, 9.071. Now we're subtracting numbers with a different number of decimal places. So first we have 37.8 minus 14.671. Now we can use column subtraction for this, but it's really important that we write the numbers out with the decimal points lined up. We don't write the numbers out with the digits lined up on the right hand side, like we do when we're subtracting whole numbers. It needs to be the decimal points that are lined up, because if the decimal points are lined up, then the place values, so our tens, ones, tenths, hundredths and thousandths columns will be lined up as well. Now we have some empty squares, and we can write zeros in empty squares, because 37.800 is the same as 37.8, so we haven't changed the question, because all these zeros tell us is that we don't have any hundredths or thousandths in the number 37.8. Now we can copy the decimal point down into our answer, so that our place values are lined up in our answer as well, and now we can just subtract using column subtraction. So we can't do 0 minus 1 using the column method, and we can't exchange with the place value to the left because we have a 0. So we need to go all the way over to the tenths and exchange one of those tenths for 10 hundredths. Then we can exchange one of those hundredths for 10 thousandths. So now 10 minus 1 is 9, 9 minus 7 is 2, 7 minus 6 is 1, 7 minus 4 is 3, and 3 minus 1 is 2. So that gives us 23.129. Now we have 36.909 minus 20.67. Again, we've got the numbers written out with the decimal points lined up. So now we can write zeros in empty squares and copy the decimal point down into our answer. 9 minus 0 is 9. We can't do 0 minus 7, so go to the left, 1 less, 1 in front. 10 minus 7 is 3. 8 minus 6 is 2, 6 minus 0 is 6, and 3 minus 2 is 1. So our answer is 16.239. Now we have 6 minus 5.738. And it's important that we write the question out with the 5 ones in our decimal underneath the 6 ones that we're subtracting from. Now 6 is the same as 6.000. You can always put a decimal point and then zeros on the end of a whole number. 6.000 is the same as 6 because all the .000 tells us that is that in the number 6 we don't have any tenths, hundredths or thousandths. But now we can subtract using column subtraction, but first, so that we don't forget, let's copy the decimal point down into our answer. Now, we can't do 0 minus 8, and when we go to the left, we have a 0 and then another 0. So we need to go all the way over to the ones column and exchange one of those ones for 10 tenths, then exchange one of those tenths for 10 hundredths, and finally exchange one of those hundredths for 10 thousandths. So now 10 minus 8 is 2, 9 minus 3 is 6, 9 minus 7 is 2, and 5 minus 5 is 0. That gives us 0.262. Let's take another look at this first question, but let's use place value counters so we can see what we did. We started with 37.8, so that's 3 tens, 7 ones, and 8 tenths. First, we wanted to subtract 1 thousandth, but to do that we first had to exchange one of our tenths for 10 hundredths, so we can take one of our tenths and exchange it for 10 hundredths counters. Then we took one of those hundredths and exchanged it for 10 thousandths, so we can take a hundredth counter and that's the same value as 10 thousandths. So now we can take 1 thousandth away to leave us with 9 thousandths. Then we subtracted 7 hundredths, so if we take away 1, 2, 3, 4, 5, 6, 7 hundredths, that leaves us with 2 hundredths in our answer. Then we subtracted 6 tenths to leave us with 1 tenth. We subtracted 4 ones to get 3 ones in our answer, and we subtracted 1 10. So that gave us an answer of 23.129. So 2 tens, 3 ones, 1 tenth, 2 hundredths, and 9 thousandths. Then we started with 36.909. So that's 3 tens, 6 ones, 9 tenths, no hundredths, and 9 thousandths. We didn't need to subtract any thousandths, so the 9 thousandths remained in our answer. We did need to subtract 7 hundredths, but to do that, because we didn't start with any hundredths, we had to exchange one of our tenths for 10 hundredths. So we can take one of our tenths counters, and because that's the same as 10 hundredths, we can now subtract 7 hundredths, 1, 2, 3, 4, 5, 6, 7, and that gives us 3 hundredths in our answer. Then we subtracted 6 tenths to get 2 tenths in our answer. We didn't subtract any ones, but we subtracted 2 tens, and that left us with 16.239. Finally, we started with 6, so that's 6 ones. But first, we wanted to subtract 8 thousandths. To do that, first, we had to exchange one of our ones for 10 tenths. Then we had to exchange one of those tenths for 10 hundredths. And then we exchanged one of those hundredths for 10 thousandths. So then we could subtract 8 thousandths to leave us 2 thousandths in our answer. we could subtract 3 hundredths. That left us with 6 hundredths. We could subtract 7 tenths. That meant we had 2 tenths in our answer, and then we were subtracting 5 ones. So there were no ones in our answer. That's 0.262. Now we need to make decimal number bonds to 1. So first, 0.294 plus what equals 1 whole. What I like to do is solve these by counting on. So if we start at 0.294 and first add 0.006, so 6 thousandths, that gives us 0.300, just as 294 plus 6 equals 300. But we don't usually write zeros on the end of decimals, so we have 0.3. Now from 0.3, if we add 0.7, that gives us 1.0, which is the same as 1 whole. So we added 6 thousandths, no hundredths, 7 tenths, and obviously no ones, so we added 0.706 to get to 1, so that's our missing number. Now we start with 0.538. If we take that and add 0.002, so 2 thousandths, that gives us 0.540, just as 538 plus 2 is 540. But we don't need to write zeros on the end of decimals. Now, from 0.54, we can add 0.06, so 6 hundredths, and that gives us 0.60, just as 54 plus 6 gives us 60. We don't need to write zeros on the end of decimals, but now, from 0.6, we can just add 0.4, so 4 tenths, and that gives us 1.0, or 1 whole. So we can add what we added. We added 2 thousandths, then 6 hundredths, then 4 tenths. So altogether we added 0.462. The other way to solve these is to take 1 and subtract 0.294. So we need to write the 0 ones in our decimal underneath the 1 whole so that our place value columns are lined up. Now 1 is the same as 1.000. You can always write a decimal point and then zeros on the end of a whole number, because all the zeros tell us here is that in the number 1 we don't have any tenths, hundredths or thousandths. But now we can copy down the decimal point into our answer and subtract using column subtraction. We can't do 0 minus 4 using the column method, and if we go to the left we have a 0, then another 0. So we need to exchange our 1 whole for 10 tenths, then exchange one of those tenths for 10 hundredths, and exchange one of those hundredths for 10 thousandths. Now 10 minus 4 is 6, 9 minus 9 is 0, 9 minus 2 is 7, and 0 minus 0 is 0. So that gives us 0.706, so the same answer. Now, for this question, we could have solved it by working out 1 minus 0.538. Now 1 is the same as 1.000. We can copy down the decimal point. Now we can't do 0 minus 8, so we exchange, then exchange again, and again. And now 10 minus 8 is 2, 9 minus 3 is 6, 9 minus 5 is 4, and 0 minus 0 is 0. So again, we get our missing number. Now let's look back at this first question. We started with 0.294 and needed to make 1 whole. First, we added 6 thousandths. So if we add 1, 2, 3, 4, 5, 6 thousandths, we now have 10 thousandths. So we can exchange those for 1 hundredth. But doing that means that we now have 10 hundredths. So we can exchange those 10 hundredths for 1 tenth. So adding the 6 thousandths gave us 0.3, or 3/10. Then we added 7/10, so 1, 2, 3, 4, 5, 6, 7, and that gave us 10/10, which is the same as 1 whole. So because we added 6/1000ths and then 7/10, our missing number bond is 0.706. Then we started with 0.538, so that's 5/10, 300ths and 8/1000ths. First, we added 2/1000ths. When we do that, we get 10/1000ths, which is the same as 100th. So that leaves us with 400ths, and with the 5/10ths gives us 0.54. Then we added 600ths, so if we add 1, 2, 3, 4, 5, 600ths, that means we have 10/100ths, so can exchange those for one more tenth. So that gives us 0.6 because we have 6/10. Finally, we added 0.4, so that's 4/10, and that gives us 10/10, which is the same as 1 whole. So because we added 2/1000ths, then 600ths, then 4/10, our missing number bond was 0.462. Now we have some missing number addition and subtraction problems. But this first question isn't really a missing number problem at all. We have something equals 29.5 plus 9.453. Now all we've got on the left of the equal sign is an answer box, and it doesn't matter whether the equal sign is at the start, like it is here, or at the end, like it usually is. We do the same thing. We just need to add 29.5 and 9.455. But because we're adding decimals, we need to remember that we don't line the digits up on the right hand side. Instead, what we do is line up the decimal points, because if the decimal points are lined up, then the place values in our question, so our tens, ones, tenths, hundredths and thousandths, will be lined up as well. Now we can write zeros in these empty squares, because 29.500 is the same as 29.5. We haven't changed the question, because all these zeros tell us is that we don't have any hundredths or thousandths in 29.5. Now we need to remember to copy the decimal point down into our answer so that our decimal points are all lined up. And now we can use column addition. 0 plus 3 is 3, 0 plus 5 is 5, 5 plus 4 is 9, 9 plus 9 is 18, so 1, 8, and 1 plus 2 is 3. So our answer is 38.953. Now something plus 2.074 equals 14.5. So here we have a missing addition problem, and whenever we have a missing number in an addition, we always use the inverse operation, so we use subtraction to find our missing number. We need to work out 14.5 minus 2.074. So we have our decimal points lined up, which means the place values in our question will be lined up as well. We can write zeros in these empty squares and copy the decimal point down into our answer. Now we can't do 0 minus 4, and if we go to the left we have a 0. So we go all the way over to our tenths column, 1 less, 1 in front, and then again 1 less, 1 in front. Now 10 minus 4 is 6, 9 minus 7 is 2, 4 minus 0 is 4, 4 minus 2 is 2, and 1 minus nothing is 1. So our missing number is 12.426. Now something minus 1.082 equals 3.82. So here it's the first number of the subtraction or the minuend that's missing, and when it's the first number of a subtraction problem that's missing, we use the inverse operation, so we use addition to find our missing number, because remember, subtraction problems can be read backwards as addition problems. So we can work out 3.82 plus 1.082 to find our missing number. We have our decimal points lined up. We can write zeros in empty squares and copy the decimal point down into our answer. Now 0 plus 2 is 2, 2 plus 8 is 10, so 1 0, 1 plus 8 plus 0 is 9, and 3 plus 1 is 4. So our missing minuend is 4.902. Finally, 4.04 minus something equals 3.978. So this time it's the second number in our subtraction, so the subtrahend that's missing. And when the subtrahend is missing, we still use subtraction to find our missing number. So we need to work out 4.04 minus 3.978, and that will give us our missing number. Our decimal points are lined up, so we can write a 0 in this empty square and copy the decimal point down into our answer, so that's lined up as well. We can't do 0 minus 8, so go to the left, 1 less, 1 in front. 10 minus 8 is 2. Now we can't do 3 minus 7, and when we go to the left we have a 0. So we go to the left again, 1 less, 1 in front, and again 1 less than 10 is 9, so we can put a 1 in front of the 3 in our hundredths to give us 13 hundredths. 13 minus 7 is 6, 9 minus 9 is 0, and 3 minus 3 is 0. So our missing subtrahend is 0.062. We need to round the numbers below to the nearest whole number. So first we have 2.3. To round to the nearest whole number, we need to find our ones digit, which is always the digit before the decimal point. Then, to see whether we're rounding up or down, we underline the next digit, so the tenths digit. We can see that 3 is less than 5, which means that we're rounding down. That means the 2 stays the same, so our answer is 2. 2.3 to the nearest whole number is 2. And we can see on a number line that 2.3 is between the whole numbers 2 and 3. But it's closer to 2, so we round down to 2. Now we have 3.9. So to round to the nearest whole number, we circle the ones digit and look at the tenths. We have 9 tenths, and remember, if the digit is 5 or more, we're rounding up. So 3.9 rounds to 4. And we can see on a number line that 3.9 is closer to 4 than it is to 3, so we're rounding up to 4. Now we have 7.08. This time there are 2 digits after the decimal point, but that doesn't matter. We do the same thing. We find our ones digit and we look to our tenths, and it doesn't matter what comes after the tenths digit, because to decide whether we round up or down, we only look to the place value to the right, so to the tenths. Now we have a 0, which means we're rounding down, so the 7 stays the same, so 7.08 to the nearest whole number is 7. And we can see on a number line that 7.08 is between the whole numbers 7 and 8, and what we have labelled with the squares are tenths. Now 7.08 is just a little bit less than 7.1, so you can see that it's clearly closer to 7 than it is to 8. Finally, we have 5.544. So we have 3 digits after the decimal point, but that doesn't matter because we still do the same thing. We find our ones digit and look at our tenths digit. Because we have 5 or more, we have 5 tenths, we know that we're rounding up. So 5.544 rounds to 6. And we can see on a number line that 5.544 is between 5 and 6, and it's also between 5.5 and 5.6. we need to round the numbers below to the nearest tenth. So first, we have 2.36. To round to the nearest tenth, we need to find the tenths digit, which is always the first digit after the decimal point, and then we can underline the hundredths digit. We have 6 hundredths, and if we have 5 or more, we're rounding up. So 2.36 rounds to 2.4, because the digits before what we've circled stay the same, so the 2 in the ones stays the same, but because we're rounding up, the 3 changes into a 4. And we can show 2.36 on a number line. If each of these squares is 100th, we can see that 2.36 is between 2.3 and 2.4, but because it's closer to 2.4, 2.36 rounds to 2.4. Now we have 2.63. So to round to the nearest tenth, we find the tenths digit and look to the right, so look at our hundredths digit. We have a 3, and when we have 4 or less, we round down. So that means the digit that we've circled, so the tenths digit stays the same. So we have 2.6, because the 2 in the ones stays the same as well. And on a number line, we can see that 2.63 is between the tenths 2.6 and 2.7, but because it's closer to 2.6, that's what it rounds to. Now we have 4.808, so this time we have 3 digits after the decimal point, but the thousandths digit doesn't make a difference when we're rounding to the nearest tenth. We do the same thing. We find the tenths digit and underline the hundredths digit. Now we have a 0, so we're rounding down. That means the 8 stays the same, and digits to the left of what we've circled stay the same as well. So 4.808 rounds to 4.8. We can see on a number line that 4.808 is closer to 4.8 than it is to 4.9, so we're rounding down. We can also see on this number line that 4.808 is between 4.8 and 4.81. Finally, we have 6.464. So we can find our tenths digit. Again, it's always the first digit after the decimal point. We can underline our hundredths, and because we have a 6, we know that we're rounding up. So the tenths digit increases by 1, so goes from 4 to 5. Digits to the left stay the same, so we have 6.5, because if we're rounding to the nearest tenth, we don't write any digits after the tenths digit, so we only have 1 decimal place in our answer. And also, rounding to the nearest tenth and rounding to 1 decimal place, they mean the same thing. Whether we're rounding to the nearest tenth or to 1 decimal place, we only have 1 digit after the decimal point. So we can show 6.464 on a number line. We can see that it's closer to 6.5 than it is to 6.4. We can also see that 6.464 is between 6.46 and 6.47. Now we need to round the numbers below to the nearest hundredth. So first we have 0.381. Remember, the hundredths digit is always the second digit after the decimal point. So if we're rounding to the nearest hundredth, we can circle the second digit after the decimal point and then underline the digit to the right. So underline the thousandths digit. Now remember, when we have 4 or less, we round down. And because we have a 1 in our thousandths, we round down. That means the 8 in our hundredths stays the same, and digits to the left of what we've circled always stay the same, So 0.381 to the nearest hundredth is 0.38. We can show 0.381 on a number line. We can see that it's between the hundredths 0.38 and 0.39, but because it's closer to 0.38, because each of these squares is 1,000th, we round down. Now we have 1.405. So again, we find our hundredths digit, which is always the second digit after the decimal point, and we look to the right, so to the thousandths digit. Remember, if it's 5 or more, we round up, and we have a 5, which means the 0 in our hundredths turns into a 1. Digits to the left stay the same, so we get 1.41. We can see on our number line that 1.405 is right in the middle of 1.40 or 1.4 and 1.41. But if a number is right in the middle, then we always round up, not down. Now we have 5.598. So we can circle our hundredths digit and look to the right. We have an 8, so we're rounding up. But we already have 9 in our hundredths, and we can only have one digit in each place value. So what we need to do here is to circle the tenths and hundredths together. So 1 more than 59 is 60. So because we're rounding to the nearest hundredth, we can have 5.60, but we don't need zeros on the end of decimals, so we can write 5.6. We can see on a number line that 5.598 is closer to 5.6, which is the same as 5.60, than it is to 5.59, so we can see that we need to round up. Now we have 6.107. To round to the nearest hundredth, we find our hundredths place and look to the thousandths. Here we have a 7, so because it's 5 or more, we know that we're rounding up. So the 0 in our hundredths becomes a 1, and digits to the left stay the same, so we have 6.11. On a number line, we can see that 6.107 is closer to 6.11 than it is to 6.1 or 6.10, so that's why we round up. Now we need to divide decimals by 10, 100 or 1,000, and to do that we always start in the same way. We write out our decimal, so here we have 0.68, and we copy down the decimal point. Now we're dividing, so digits are going to move to the right to make the number smaller, and dividing by 10 means digits are moving one square to the right. And the way to remember that is that the number 10 has 1 0. So if we copy down this 8, 1 square to the right, do the same with this 6, and with this 0, we get 0.068. But we know that the digit before the decimal point is our ones digit, and we can never have an empty ones column. So we need to write 0 in this empty square, and that gives us our answer, 0.068. Now we have 80.08 divided by 10. So we write the number out and copy down the decimal point. We're dividing, so digits are moving to the right, and dividing by 10 means we need to move the digits one square. So we can copy down this 8, 1 square to the right, do the same with this 0, with this 0, and with this 8. So that gives us our answer, 8.008. Now we have 0.7, so we can write the number out and copy down the decimal point so that it's directly below the decimal point in our number. But this time we're dividing by 100. We're dividing, so digits are still moving to the right, but to divide by 100, we need to move the digits 2 squares to the right. The way to remember that is that in the number 100, we have 2 zeros, so digits move 2 squares. we can copy down this 7, 1, 2 squares to the right and do the same with this 0. But now we have an empty square before the decimal point, and if we have empty squares before the decimal point, we need to write 0 in that empty square, so that the 7 is in our thousandths place value. We also need to write a 0 before the decimal point, because we can't have an empty ones column. So that gives us 0.007 as our answer. Now 2.06, so we write the number out and copy down the decimal point, and we're dividing by 100. So because we're dividing, digits are moving to the right, and dividing by 100 we have 2 zeros, so digits move 2 squares to the right. The other way to think about dividing by 100 is that dividing by 100 is the same as dividing by 10 and then by 10 again. So, because dividing by 10 moves the digits 1 square to the right, if we're dividing by 100, we need to move the digits to the right again. So we need to move the digits 2 squares to the right. So we can copy down this 6, 1, 2 squares to the right, do the same with the 0 and with the 2. Now, again, we've got an empty square after the decimal point, so we need to write 0 here and a 0 before the decimal point, and that gives us 0.0206. Now we have 34.1. We can copy down the decimal point, but this time we're dividing by 1,000. Now we're dividing so digits move to the right, and in 1,000 we have 3 zeros, so digits need to move 3 squares to the right. So we can copy down this 1, 2, 3 squares to the right, do the same with the 4 and with the 3. Now we need to write zeros in the empty square after and before the decimal point to give us 0.0341. Now we have 146.1, so we copy down the decimal point, and to divide by 1,000, the digits move 3 squares to the right. The way to remember that is that 1,000 has 3 zeros, and what we're really doing when we divide by 1,000, we could think of as dividing by 10, then by 10 again, and then by 10 for a third time, because if we divide by 10 3 times, that's the same as dividing by 1,000, so that's why the digits move 3 squares to the right. So if we copy down this 1, 2, 3 squares to the right, and do the same with our other digits, we now have an empty ones column, so we can write a 0 in the square before the decimal point to give us 0.1461. Now we need to multiply decimals by 10, 100 or 1000, and to do that we always start in the same way. We write out our decimal, so here we have 40.01, and then we copy down the decimal point so that it's directly below the decimal point in our number. Now when we multiply, digits move to the left, and we're multiplying by 10, which has 1 0, so digits move 1 square to the left. So we can copy this 4 down, 1 square to the left, and do the same with all of our other digits. That gives us 400.1 as our answer. Now we have 6.1, so we write the number out and copy down the decimal point, and to multiply by 10, the digits move 1 square to the left. And that makes sense, because when we have 10 of something, we can exchange it for 1 of the place value to the left. So to multiply by 10, we move the digits 1 square to the left. So if we do that, we get 61 and then a decimal point. Now if we have a decimal point on the end of our number, we have a whole number. So 6.1 times 10 is 61. And that makes sense, because 6 times 10 is 60, and 1/10 times 10 is 1, because if we have 1/10 and we multiply it by 10 so that we have 10 tenths, 10 tenths is the same as 1 whole. Now we have 36.21, so we write the number out and copy down the decimal point, but this time we're multiplying by 100. Now multiplying by 100 is the same as multiplying by 10 and then by 10 again. So to multiply by 100, the digits move 2 squares to the left. So we can copy down this 3, 2 squares to the left, and do the same with all of our other digits. That gives us 3,621, and the decimal point is on the end, which means we have a whole number. So our answer is 3,621. Now we have 0.6, so we write the number out and copy down the decimal point, and we're multiplying by 100, which means digits will move 2 squares to the left. The way to remember this is that 100 has 2 zeros, so digits move 2 squares, and when we multiply, the number gets bigger, so the digits are moving to the left, because to the left we have our larger place values. So we can copy this 0 down 1, 2 squares to the left, and do the same with this 6. But now we have an empty square before the decimal point, and we know that the digit before the decimal point is the ones digit, so we need to write a 0 in this empty square to show that the 6 has now moved into the tens column. So that's 060 with a decimal point now on the end. When the decimal point is on the end, we have a whole number, and we don't need this 0 in our hundreds. We can just write our answer as 60. Now we have 5.8, so we write the number out and copy down the decimal point, and this time we're multiplying by 1,000. Now multiplying by 1,000 is like multiplying by 10 and then by 10 again and then by 10 for a third time, and that's why to multiply by 1,000 we need to move our digits 3 squares to the left. So if we copy down this 5, 1, 2, 3 squares to the left, and do the same with this 8, we now have 2 squares before our decimal point. So we need to write zeros in these empty squares to show that the 5 has now moved to the thousandths column and the 8 to the hundredths. So our answer is 5,800, because now the decimal point is at the end, we have a whole number. And that answer makes sense, because we know that 5 times 1,000 is 5,000, and 6 times 1,000 is 6,000, so because 5.8 is between 5 and 6, our answer is between 5,000 and 6,000. Finally, we have 7.05 times 1,000, so we write the number out, copy down the decimal point, and to multiply by 1,000, the digits need to move 3 squares to the left. We can copy the digits 1, 2, 3 squares to the left, and now we have an empty square before the decimal point, so we need to write a 0 in this empty square, so our answer is 7,050. And again, that makes sense. We know that 7 times 1,000 is 7,000, and 7.05 is just a little bit more than 7, so our answer is a little bit more than 7,000. So use estimation to check that your answer makes sense.